this is Eric Helvitis and Ben Plower from Anderson Global. Today we're going to be looking at a closer look at one of the services we provide here at Anderson Global, which is simulation. Ben, could you kind of give us a rundown of our capabilities?
Yeah, sure, Eric. Welcome everybody. Basically, I'll just go over a quick overview of the solidification simulation and some of the services that we're able to provide. Basically, it really works hand in hand with the design for manufacturing of the castings. But typically, starting off, what we'll do is we'll run what they call a natural solidification. I'll kind of play it here as you can see. What this does is it just naturally shows us where we could potentially have some problems, where the heavy isolated volumes are going to be at, and just gives us a good indication, a starting point, right? What that's going to tell us is how complicated the casting is going to be right off the get-go. Basically help us understand that a little bit better.
Okay, and there are areas that show up, and if there's a chance to change the casting, this is kind of a good indication of where we might need to make modifications, right?
Yeah, this is definitely the starting point. This in hand with your, in the previous video we did with the thin sections, thick sections, wall thicknesses, draft, things like that, it's going to point out some of the issues of solidification with the casting. So once that's done, typically we'll move into a little bit more detailed phase, and we'll have some back and forth with the customer determining, hey, what's your casting orientation preferences, things like that. Once you get some of the initial questions dialed in, then we'll begin to run some of our simulations. Now, as we're going down, we're able to check for metal velocity, the aluminum solid fraction. This tells you whether my aluminum is going to be too cold by the time it fills it up. I'm going to have any cold shuts, things like that. Solid fraction have flow in. It actually, as it goes through, it shows you exactly the mold temperatures, what's predicted in that particular state. The flow in is basically the metal front and shows you how the temperature of that metal as it gets towards the top. What you want to see is a solid blue color all the way around here for us. If it gets up into the red, then that's telling us that we're going to have a potential problem. Here's metal velocity. What we're looking for is to avoid turbulent flow, nice fill from the bottom up.
Okay, so typically you run like a baseline and then adjust with just different iterations and different configurations to try to alleviate those issues.
Yeah, we try to start a little bit simpler, what's going to make it easier to post-process the casting, optimize the yield a little bit better, things like that. And as we go, as we determine and come across items that if we have too high a velocity, what are we going to do? Do we need to adjust the choke in the runner? Do we need to add in additional in-gates, adjust the in-gate size, things like that. And the same thing as it goes down to solid fraction. If it's getting to be too cold, got to figure out how else to get that metal in there faster, hotter. Sometimes it maybe takes adding in another additional gate, items like that. So in addition to the velocity and solid fraction, it also predicts the solidification, as you can watch here. Let's see if we can speed it up just a little bit as it goes. And as you can see now, rather than just the natural solidification, we have it where we've added risers, and now we want to keep these other details feeding towards those risers. But as we see little issues, is where we would start to then dial those in. As we go down through, and we have a specific set of parameters that we want to work within. Once we feel that we've met all of those parameters, we'll try to have a final review with our customer. We'll walk down through all of the issues and potential issues we see, any additional information, make sure that everybody's happy. Then we would then proceed into the tool design once everybody has approved and happy with the solidification model.
Okay, so this is all in an effort to try to troubleshoot any potential problems that could happen at the foundry, and they have the physical tool just kind of ahead of that.
Yeah, I mean, the biggest advantage for solidification is to get you much closer right out of the gate. There's definitely, it's not a perfect science. It is left to interpretation a lot of different times. But the biggest reality is do some solidification simulation up front. It saves you time and money later on for revisions, things like that that might come up that you would have already accounted for.
Okay. All right. I think that's a really good overview of our simulation. Thank you very much for your time, Ben.
All right. Thanks, Eric.
All right. And if anybody watching this would like to reach out, there'll be a email and phone number at the end of this video, and you can also subscribe. Thank you.